Hello, today we are going to talk about developing the unit circle. And you can probably guess from the name that unit means one and what a circle looks like. So this is probably going to be a circle with a radius of 1. Before we begin here, we're going to start off by just sketching some of our special triangles. So we have a 45, 45, 90. That's one special triangle. And these have lengths of 1, 1, root 2. Then we have our 30, 60, 90 triangle with a special relationship. And I always like to think, I know it's got a 1, 2, 3 relationship. And the longest leg, it's got a 1, 2, root 3 relationship. And if you put this in order of length, I know that root 3 falls somewhere between the square root of 1 and the square root of 4. So I know that this integer of 1 and 2 is going to be smaller than 2. So if I put it in order, 1 is my smallest leg, root 3, and then 2. That helps me identify on my triangle which leg is which. So our longest leg, being the hypotenuse, is 2. The next longest leg across from my 60-degree angle is root 3, and my shortest leg being 1. From here, we can start completing the chart below, and let's go ahead and look at the sine of 30 degrees. So if I look over here at 30 degrees, the sine of 30 degrees is opposite over hypotenuse, so 1 over 2. The sine of 45, opposite over hypotenuse, 1 over root 2, which we simplify to be, rationalize the denominator, so it's root 2 over 2. The sine of 60, we have root 3 over 2. And we can't go any more with 0 and 90. So we're going to go over to cosine now. So the cosine of 30 is adjacent over hypotenuse, root 3 over 2. The cosine of 45, 1 over root 2, rationalize that again, root 2 over 2. The cosine of 60 is 1 over 2. And now we'll go ahead and do tangent. Tangent of 30. Remember, I'm getting all of this from our SOHCAHTOA. You could be pressing pause and trying to fill it in yourself. So tangent is just opposite over adjacent. So if I'm standing at 30, opposite over adjacent is 1 over root 3. And if we simplify that, we get root 3 over 3. Opposite over adjacent. Yep. And then if we do tangent of 45, tangent of 45 is opposite over adjacent, so 1 over 1, that's just 1. And the tangent of 60, opposite, root 3 over 2. Now we run into a bit of a problem when we're looking at 0 and 90. So we are going to go over to the unit circle and see if we can find any relationship with these. I am going to bring you over here, and you can just watch for a minute while I kind of work through this. My unit circle I know has a radius of 1. So let's just say that we put in a 30-degree angle here all the way to the edge of my circle. So this here is 30 degrees. I'm going to drop a perpendicular, and I'm going to try to figure out what kind of relationship I have in here. So I'm going to go down here and do a little bit of work. If I have a 30, 60, 90 triangle, I know that it has a relationship of 1, root 3, 2. So I'll fill that in. Here's 2. My 60-degree angle is my root 3, opposite, and 1. Now if I wanted to relate that to this triangle and try to see if I can come up with some kind of relationship, I know that in this triangle because it is a unit circle, it has a radius of 1. So let's see if we can come up with some kind of proportion here. Sorry, my triangles aren't looking very straight. I can fix that a little bit. So let's see, 90 degrees. I don't know if it's much better. So we have 1, 30 degrees, and 60. So if I wanted to scale this, to go from 2 to 1, I need to divide by 2 or multiply by 1/2. So I'm going to follow that same scale, multiply this by 1/2, so I have root 3 over 2. Multiply 1 by 1/2 and I get 1/2. So that means the length here is root 3 over 2 and the height of my triangle being 1 over 2. So this coordinate point, we did this before, is just our xy ordered pair. So it's root 3 over 2 comma 1/2. So if we look back at our relationship of our 30, 60, 90, how does that relate to, let's look at 30 degrees and root 3 over 2. So 30 degrees, root 3 over 2 is our cosine of 30 degrees. So if we look back up here, this was just our cosine of theta, which was our 30 degrees. Now let's look, how does 1/2 relate to 30 degrees? Go back here, 30 degrees, 1/2 is our sine. So this coordinate point is actually just cosine sine. So all the and we could throw in all of our triangles and find out all the relationship here is cosine comma sine. So if we look at 0 degrees, which means I am right here, this is 0 degrees, we can look at this coordinate point. That coordinate point is 1, 0. So at 0 degrees, I have cosine is 1 and sine is 0. So I'll go back here. At 0 degrees, remember our unit circle, 0 degrees, this coordinate point here is 1, 0. So this would be cosine sine. So cosine is 1 and sine is 0. Well, we can figure out tangent because we all know we get tan in Southern California. That's how I remember it. So it's sine over cosine. So tangent of 0 is 0 over 1, which is 0. Now let's take a look at our 90. We can again relate this to our unit circle. 90 degrees is here. And that coordinate point, if this is a unit circle, is 0, 1. So the sine of 90, this is cosine comma sine, the sine is 1. My cosine is 0. And my tangent is 1 over 0, which is undefined.